Okay. So today we'll start this topic on force, work, and energy. So we'll discuss everything that we need to know about force, work, and energy, and then we have some questions from previous year Olympiad, so that we are going to discuss. Okay. Um, what is force? Force is basically any push or pull that we apply to an object, right? And what can a force do? Force can affect the motion of an object. What does motion mean? It means the state of a body. Say it can be at rest or it can move. So we can stop a moving body, or we can make a body at rest move using by applying some force onto them. The definition of force says it is either a push or a pull, right? We need to look at the definition of what a push or what a pull is. Okay. So push basically means to move something away from yourself, right? So, for example, this person is pulling the cart away from himself. So push basically means you're pushing something away from yourself, whereas pull means you're pulling something towards you. So move something towards you. For example, this kid is pulling this object towards him, and this person is pushing this cart away from him. So this is the difference between push and pull. So this person is applying a force to push a body, and this kid is applying a force to pull an object. So you'll see application of force in both the cases, be it pull or push. Okay. So I have four illustrations, all of which denotes either a push force or a pull force. For example, the first, so you have some kids, so they are pushing this object away from themselves. So this is a kind of push force because they are pushing it, right? This person is pulling this object towards her, right? So she's pulling this bag towards her. So this is a type of pull force. These kids, so they are pulling this bell, right, towards themselves. So it is a pull force. And then this person is pushing the swing away from himself. So this is why it is a push force. Okay. So then we have different examples of forces. So gravitation force is an example of a force. Applied force or muscular force is an example of force, and magnetic force is also an example of force. Gravitational force is the force by which anything is attracted towards the center of Earth. Applied force or muscular force is the force in which we use our muscles to apply force on a body. And magnetic force is the force that magnets apply to magnetic materials. So for example, if you take a magnet and then you have iron fillings, so the iron fillings will be attracted to the magnet. So the iron fillings will be pulled by that magnet by the pull force. Okay. Then force has certain potential. So what can a force do? It can alter the state of motion of an object, right? So there are different things that force can do, basically four things. So the first thing is it can make a stationary object move. So if you have a stationary ball, right, if you kick that ball, it will start to move. So this is one of the effects of force. It can also stop a moving object. So if you have a moving ball, so you can stop it, or say if someone throws a ball at you, you can just grab it. Right, so this is an example of how you can use force to stop a moving object. It can alter the pace of an object. So if an object is moving slowly, you can make it move faster by applying force. If an object is moving faster, then you can apply that force to make it slower. And at the same time, it can also change the direction of a moving object. So if an object is moving in this direction, you can apply force in this direction. So it will start moving in this direction. Okay, so these are the four actions of a force. Four results or four effects of a force that you can get either by applying push or by applying pull. Okay, so there are three different activities. So we just have to categorize whether these are push force or a pull force, and then what will be the effect of applying push or pull. Will it stop an object or will it move an object? So just follow along while I try to solve this. So for the first example is opening a door. So it is a pull force. Right. So when you are opening a door, so you are pulling it towards yourself. So that is why it is a pull force, right? And because of this, so when the gate was closed, or when the door was closed, it was at rest position. So it will start to move when you apply that pull force, right? Yeah. So it will start to move. Then you are moving the wheelbarrow. So it is just like a cart, small cart. So when you move that wheelbarrow, so you are basically pushing it away from yourself, right? So that is an example of a push force, right? And again, initially the wheelbarrow must be at rest. So when you are pushing it away from yourself, so you've started giving it motion, right? So that object will start to move by the action of force, or the push force that you apply. So it will again start to move. And then finally, when you catch a ball, so someone is throwing a ball at you, right? At that point of time, when someone is throwing that ball, it is moving. And what you do, you try to grab that ball and pull it towards yourself so that you don't get the impact of that ball on your body, right? Yeah. So it will stop the movement, and it is an example of a pull force. Why? Because you are pulling it towards yourself. When you grab a ball, you pull the ball towards yourself. Okay, so before we move on to different types of forces, we'll just revisit what we have discussed. So force is basically push or pull on an object. So it can either stop, move, or change the direction of an object. So it can have three effects. And we also saw what is the difference between push and pull. So push means to move something away from you, while pull means to move something towards you. So these are the two categories of forces. I mean, you can either push an object using a force or pull an object using a force. Then, I mean, what force does is it alters the state of motion. So if an object is at rest, you can apply force to move it. If an object is moving, you can apply force to stop it. So it is the movement or change in position of an object resulting from force. Okay. So then we have the different types of forces. The first type is contact force. Second type is non-contact force. So contact force, as the name suggests, so when you have two bodies in contact with each other, a force is being generated. So without that contact, you won't have that, you won't feel the presence of that force. So that is known as contact force. So contact forces are the forces that act between two objects that are physically touching each other. So for example, you have this person, he is moving this object, right? Or he is pushing that object, right? Type of force is told earlier, push, pull. Yes, so see, force is basically push or pull, right? So force can be push or pull. Now, based on how this push or pull is happening, so you then classify that as contact force and non-contact force. So for example, you pull someone by applying force on that object, right? So you're pushing this thing by applying force, but at the same time, earth is pulling you towards the center. So if you jump from the floor, so what will happen? You'll come back to the floor. Why is this happening? Because earth is attracting you towards the center of itself. Because earth is a sphere, right? So earth will try to attract you towards its center, and then you will come back to the initial position or to the ground. You will not keep flying if you jump, right? But you know that there is no contact between you and the earth when you are at this height. Say at here. At this point, there is no contact between you and the earth, but still earth is applying some force on you. Right? So when there is no contact between two bodies, so it is known as no contact, non-contact force. But when there is contact between bodies, it is known as contact force. So the types of force can change based on, I mean, what is the context we are talking about, right? And then we also cases wherein we have two more types of force. One is balanced, the other is unbalanced. So balanced force means when you are applying same force in opposite direction. Unbalanced means when you are applying unequal forces in opposite direction. So, I mean, there can be different types of forces based on what we are talking about. Earlier, we are talking about what we are trying to do. We are trying to push something or we are trying to pull something. So that was the type of force on that basis. Here, we are trying to see when we are pushing something or pulling something, is there a contact between the bodies or is there no contact between the body? If there is a contact, it is known as contact force. If there is no contact, It is known as non-contact force. Okay. So contact forces are the forces that act between two objects that are physically touching each other. Right. So if we again look at the previous examples, right? So if we look at the previous example, so this is a pull force, and at the same time it is also a contact force because the bodies are in contact. So all three of them are currently, so all the three forces that we are studying are examples of contact forces as well. Because when you are applying force on that body, you and the body is in contact. So that is why it is an example of contact force. Right. Whereas non-contact forces, so these forces can act between two objects without them physically touching each other. So the example of magnet that we saw. So if you have a magnet and then you have some iron fillings, right? Or say you have two magnets aligned towards each other, right? So they can either attract or repel, right? So when they are attracting, is there any contact between these two bodies? There is no contact, right? So that is why this type of force wherein there is no contact between the body, but still they are getting attracted, getting pulled or pushed, is an example of a non-contact force. Because you know that magnet can either pull, I mean, they can come close to each other or they can push, right? So they can repel as well as attract based on what poles we have taken. So that is why, I mean, it is not always necessary that for you to apply force, there has to be physical contact. So force can also be applied when there is no physical contact. For example, in case of magnet, in case of gravity. So these are all examples of non-contact forces. Right? So, I mean, contact forces, the example are friction, resistance, tension, and applied force. So friction is basically, okay, so we'll study each of this in detail in the next slide. So I'm not going to detail as of now. Non-contact force, you have gravity, magnetic force, and electrostatic force. So these are some examples of contact versus non-contact forces. So the first example, it was frictional force, right? So what is friction? So friction is a type of force that opposes the motion of an object. Right. So it is a force that happens when two surfaces rub against each other. Right. So you have this surface, right? This floor is a surface, and then this body, you are trying to move this body, or you are trying to push this body away from you and this against this floor. So you will see there is some resistance coming from the floor. Right. Why is that resistance coming? It is because of a type of contact force which is known as friction. Okay, so it is like a sticky force that can make things harder to move smoothly. So, example, so if you are pushing a heavy box, it is harder than pushing a lighter box. So if you have a heavy box, it becomes difficult for you to push that box. Whereas if you have a lighter box, it becomes easier for you to push that box, right? Because frictional force between box and floor varies based on the weight of that body. So if you have a heavy body, it is difficult to move because the frictional force is more. If you have a lighter body, it is easier for you to move. And at the same time, if you have a rough floor, if the floor is very rough like this, then also it is difficult for you to move that body on that rough force because rough floor, the friction is more. Right? Whereas if you have a smooth floor, so you must have seen that, if you have a very slippery surface, for example, water. So if you have water spilled all around the floor, or if you have done ice skating, so it is very easy for you to get slipped, right? And it is also very easy for you to move objects in smooth surfaces. Whereas in rough surfaces, it is very difficult, right? So for example, so that is an example of frictional force. Frictional force is more in rough floors. Frictional force is less in smooth floor. Okay. Another type of force is resistance force, right? So when you are doing paragliding or any activity in air, right? So you'll experience that certain thing is rubbing against your body, right? Something is rubbing. So the air, you'll experience that air is rubbing against your body. So that is an example of resistance force, right? Even in water, you experience this resistance force. If you try to move your hands in water, you'll see or experience some sort of resistance. Right, and the thicker the liquid is, the more difficult it will be for you to move your hands around that. Right, so that is why you have this. So that is where you have this resistance force. So resistance is a force that happens when something tries to slow down or stop another thing from moving, right? So for example, a paraglider stays in the air because of air resistance. The wind pushes against the paraglider and creates the force, right? So this is because of the air resistance that the paraglider is moving in the air, okay? And then you have tension force. So tension force is nothing but, say if you have tied something to a string, right? So it is a type of force wherein an object, so this force comes into picture wherein two objects, I mean two forces act in opposite direction. So for example, this person is swinging, right? So this person is swinging, and then the weight of the person is trying to pull this rope in the downward direction, whereas this hanger is trying to hold this, so it is applying a force in the upward direction on the string. So when you have two forces acting in opposite direction, another example would be two people playing tug of war. So one people pushes the string from this side, right, pulls the string from this side, the other person pulls the string from this side. So there is tension in the string, right? So this is the type of force that we call tension force, right? And if we exceed that limit, a certain limit that the rope can withhold, so then the rope tends to break, right? So it is because of tension in that rope. So such type of force, such type of force that acts when an object is pulled in opposite direction by opposite forces is known as tension force. Okay, and then we have applied force or muscular force. So applied force is a force when you have one object push or pull another object, right? So it happens when you use your muscles to push or pull an object in a certain direction. So whenever you're applying your muscles, say you're using your power to move something, it is known as applied force or muscular force. Okay. I mean, this is a question from previous year. To reduce force X on a carom board, talcum powder is applied, right? So what type of force you want to reduce in a carom board so that you apply talcum powder onto it? It will be the frictional force. So you will you put talcum powder on carom board to reduce the frictional force, right? And that frictional force is the force which is responsible to prevent us from slipping while walking. So D will be the correct answer. Okay. Which of the following is correct about the girls moving the sack bags as shown in the given diagram? So girl A has to work more against friction. Girl B does not have to work against friction. The wheels of the trolley have reduced the friction. So you can see there are two cases. This person is moving this sack of bag. I mean, there is nothing to support. And then this person is moving this sack of bag, but then you have a wheel. So the purpose of wheel is to reduce the friction, right? And then the girl A has to do more work against friction because there is no wheel to reduce the friction. And girl B does not have to do work. So it is not true that girl B does not have to do work against friction. She has to do, but the work is much lower when compared to girl A. So this is false. And the wheels of the trolley have reduced the friction. So it has not completely eliminated the friction, but it has reduced the friction. So 1 and 3 will be the correct answer. Okay. Then you have Ritesh tries to pull two different boxes filled with different items as shown in the given figure. So this box has 10 kg of wool and this box has 10 kg of rice. Again, the same difference. You can see that this particular box has wheels to support it, right? To support the movement. So you have a wheel cart. So he had less difficulty in pulling box 1 than box J than box K. What could be the possible reason, right? So this requires less effort when compared to this. Why? Because this has lower friction when compared to this, because the wheels have slightly reduced the friction. Right? The first option says the wool is lighter than rice. Both have the same weight, 10 kg, so there is no difference between the weights. There is more friction between box K and the floor. So box K and the floor has more friction. It is true, right? There is more friction between box J and the floor. So between box J and the floor, there is less friction, not more friction. So only 2 is true. This is false and this is also false. So the correct answer would be Q only. Okay. Then you have examples of non-contact force. So the first example is gravity. So gravity is a force by virtue of which objects gets pulled towards each other, right? And it is also the force by which the earth pulls any object towards its center, right? So if you are jumping, so you'll eventually come down because the earth is trying to pull you towards its center. Okay. Then you have another type of non-contact force, which is magnetic force. So magnetic force is a type of non-contact force that acts between magnets or magnetic objects. So any magnetic objects means anything that gets attracted to magnets. And then you have electrostatic force. Electrostatic force means the force that occurs between charged particles that are not moving. Right? So when you have like charges, so positive and positive, they will repel. So this is similar to gravity, but there is one difference. In gravitational force, two particles will always attract each other. But in electrostatic force, if you have like charges, they will repel. If you have unlike charges, they will attract each other. Okay. Then we have a question. The given picture represents what type of force? So an apple is falling from the tree. So what type of force is responsible for this? It is the gravitational force, right? Because anything will fall to the ground because of the gravitational force. Then you have Nishad cut the thread from which a stone was tied and suspended. He observed the changes and concluded that, so I mean, there was a thread and a stone was tied to this through a thread, and then Nishad, he cut the thread and then observed that the stone fell. So which of the following observations are correct? The first observation says air pulls the falling objects, which is incorrect. It will resist it from falling if it is falling. Gravity pulls object towards ground. This seems true, right? Because this will fall only because of gravity. The thread exerts a push on the stone. So thread will try to, so since gravity is trying to pull it downwards, so thread will try to pull it upwards. So it will apply an opposite force in the upward direction. So it will not exert push, rather it will exert a pull force. And then the stone is a weightless object. Stone is not a weightless object, it does carry some weight. Okay, so B will be the correct answer. Then again we have different, one more classification of force based on whether you are applying the same force or different force. A balanced force results when two forces with the same amount are applied in opposite direction. So when you are applying same force in the opposite direction, it is known as balanced force. And as a result of balanced force, you won't see any motion, right? If the body is moving, then it will keep moving, it will not stop. If a body is at rest, it will stay at rest because you have a balanced force. I mean, net it is zero. Unbalanced force is a type of force wherein you are applying greater force on one side whereas less force on one other side. So the force becomes unbalanced and then you can see movement in the direction wherein you are applying more force. Right, so here you can see movement in this direction. And here we have two cases. For example, here you are applying same force on a body. So since you are applying same force, so A will not move. And then when you are applying greater force on one side, so which means B will move in this direction. Right, so this side has greater force, this side has less force. So the unbalance, I mean, this force is getting unbalanced from this side. So the force, you are applying more force from this side, so the object is going to move in this side. Okay. Then we come to work. So what is work? Work has two main components. The first thing is force must be applied, and then there should be displacement in the direction of force. Right. So when both these criteria are met, we say that work is supposed to be done. Right. And the formula for work is force times displacement. Right. The SI unit of force is Newton. The SI unit of displacement is meter. So the SI unit of work will be Newton meter, which is also known as joules. Okay. Then we have this decision tree, so that we use to make decision whether work is being done or not. So to check whether work is being done or not, first thing we check is whether we are applying a force or not. If we are applying a force, then we have to go down. If you are not applying any force, that means no work. So once we have checked that, okay, force is being done, next we check is, does the object move? Is the object moving? So I've applied force, now is the object moving? If it is not moving, there is no work. If there is movement in the direction of force, right? So the object can move, but it can move in the direction of force, or it can move in a direction perpendicular to the direction of force applied. So there can be two cases again. If the object is moving in the direction of force, then only work is said to be done. If it does not move in the direction of force, then we can say that there is no work being done. Right? So work is equal to force times displacement. That is what we already discussed. So again, to check if work is being done, so force must be applied, object must move, and object must move in the direction of applied force. Then only we can say that work is being done. Okay. So yeah, so this is one case wherein we feel that we are doing work, but work is not actually happening. So say for example, we are pushing a wall does not move. So if we again go back to this decision tree, we are applying force, so this is correct, but the object is not moving, so there is no work. So if you have to do some work, first of all you have to apply a force, and then you need to have displacement in the direction of force, right? So this is an example of a case wherein work is being done. So you are moving this small car, so you are applying force, and then you see object is moving in the direction of applied force. So that is when you say work is being done. Okay. Then again we have a question. Activities like, which of the following activities are technically not considered as doing work in science because of what reason? So I mean, we have to just select the reason which is most appropriate and the activity corresponding to that as well. Okay. So first of all, reading. So is reading considered an example of doing work? So if we are reading a book, does that mean we are doing some work? It does not mean, right? Why? Because we are not applying any force, and the book also is not moving in the direction of the applied force. Pushing a stationary wall, this also does not do any work, but it is saying that no force is applied. It is not correct. Why? Because we are applying force, but there is no movement. So that is why it is incorrect. So the reason is incorrect. Reasoning is incorrect here. Right? Then thinking also involves no applied force and no movement. So that is why both A and C are the correct answer. Okay. So we have discussed force, we have discussed work. Finally, energy. Energy is the ability of a body to do work, or the capacity of a body to do work. So if a person has more energy, he will be able to do more work. If a person has less energy, he will be able to do less work. Right? And then mainly there are two types of energy: kinetic energy, potential energy. We have other various forms of energy as well, but this is mainly the mechanical energy that we are talking about. So they are mainly of two types: kinetic energy and potential energy. Kinetic energy is the energy that a body possesses by virtue of its motion. So if a body is moving, it is said to possess kinetic energy. Potential energy is the energy that a body possesses by virtue of its position. So if you are storing something above at a particular height, it will have some potential energy stored in it. And the formula for kinetic energy is half mv square. The formula for potential energy is mgh, because v square, because if an object is moving, it is said to have kinetic energy. That is why it is half mv square. If an object is kept at a particular height, it is said to have potential energy. So that is why it is mgh. So the potential energy depends on height. That is why you have height in the formula. Kinetic energy depends on speed. That is why you have speed in this formula. Okay. Then we have conservation of energy. So what does conservation of energy means? You cannot create or destroy energy. You can only convert energy from one form to the other. Right. So for example, if you have this roller coaster, right? So it is at the peak height or the maximum height. So at this maximum height, it will have 100% of the energy will be stored as potential energy. Because it is at rest at this point, it is not moving. Now, if you just give it a small push, right, so some of the potential energy will be converted to kinetic energy, will keep on getting converted to kinetic energy. At this point, when it reaches height equals to 0, when the height is 0 at this point, so it is said to have 0 potential energy. So that means all the potential energy has been converted to kinetic energy at this point. And then again, so since it has kinetic energy, it will keep on moving, and then it will reach a particular height. When it reaches a particular height, that is 50% of the starting height. So for example, initially it was at 40 meters. Now at this point, it is at 20 meters. So that means all the kinetic energy, I mean, at this point, it had all the energy in it was stored as kinetic energy. So at this point, half of that will be converted to potential energy and half of that will be converted to kinetic energy. So at this point, you'll have 50% stored as potential energy and 50% as kinetic energy. So everywhere, no matter where you go, you'll have total energy conserved. That means total energy will remain potential energy plus kinetic energy. So it will not change. So there will be 0 change in value. So until and unless there is some non-conservative force. Say for example, in real life, this is not the case because some energy will be lost via friction, right, in the form of heat. So ideally, it says the law of conservation of energy, total energy remains constant. It does not change. But in real life, it does change. So total energy is potential energy plus kinetic energy. So sometimes you'll have high potential energy and low kinetic energy. Sometimes you'll have high kinetic energy but low potential energy. Right? But if you add them both, you'll get a constant value every time. Okay. Then we have some questions on energy as well. So we have to identify the incorrect statement. So the first statement says, energy is the capacity to do work. It is correct because this is the definition of energy. So it is the ability of a body to do some work. Then you have energy cannot be changed from one form to another. We have just seen that we can convert kinetic energy to potential energy and potential to kinetic. So this is false. Potential energy is the energy due to motion. Potential energy is the energy due to height and not motion. Kinetic energy is the energy due to motion. That is why this is also false. So both B and C are incorrect. So this is the correct answer. Right? A ball is kept on the roof of a tall building. Which type of mechanical energy it possesses? Right? So you kept a ball on the roof of a tall building. So it has some height, right? And it is not moving. So since it is not moving, it does not have kinetic energy. It is stored at a particular height. So that is why you will have potential energy stored in it and not kinetic energy. Then this final question. Manav gently pushed down a toy car from top of a racing track as shown in the diagram. The arrow shows the direction of movement of the car. Which of the following statements are incorrect? So you have different scenarios, right? So this is the maximum height, right? So at this point, the car only has potential energy. Now you started to push it gently towards the ground. So what happens at different scenarios? So this point, since it was not moving, potential energy was something, kinetic energy was 0. And at this point, since it is at 0 height, that means kinetic energy is something and potential energy is 0. Right, now we have some statements corresponding to that. The car has most gravitational potential energy at P. We know that at this point it was not moving. So kinetic energy was 0. So all the energy must be stored in the form of potential energy. So this is true. The car has the most kinetic energy at P. At P it was at rest, so it has 0 kinetic energy. So that is why it is false. The car used up all its energy at U. It did not use all its energy. Potential energy got converted to kinetic energy, right? So total energy is still something. It is not 0 as per the law of conservation of energy. So that is why this is false. the car has the least kinetic energy at R. So the car has least kinetic energy at P, which is 0. But if you just compare these heights, so mgh, so this is mgh and this is half of mgh. So where is that remaining energy going? It must be stored in this car as kinetic energy only, right? So that is why it is not exactly 0. It will be half of that potential energy, not exactly 0. So the car has the least kinetic energy at R. It does not have the least kinetic energy at R. And the car has the most kinetic energy at U. This is true. And this is false. And this is true. Because at this point, potential energy is 0. So all the energy in it must be stored as kinetic energy. Okay.